So first part I want to clarify and kind of do like a checkpoint with is our concept of making equations from known zeros or intercepts or roots. So knowing that those all mean the same thing. So what I'm going to do real quick is I want to review just solving quadratics first and show you how we can kind of take that knowledge that we already know and how it works with what we're doing now. So if we take this equation, for example, we could solve this with the quadratic formula, but the quicker way, if you remember, is to factor this down. So our technique here is if when our lead coefficient's 1, we can just look at this constant number. So what factors of 15 add up to be 8? And what we did was we kind of unfoiled it. That's one way we could think of it. But we broke that up into two factors. And if that times that equals 0, what we said was that means one of these factor values has to be 0, because the only way I could get 0 multiplying two things together is if one of these things is equal to 0. And if you remember, then we talked about how the zeros or the answers are always opposites to the actual factor. So x plus 5 gave me an answer of -5. X plus 3 gave me an answer of -3. And we talked about how we could pretty much skip this step if you wanted to. Same thing here. If I wanted to factor this thing down, if I can, I want to get this number to be a 1. So this is where we could do a 2. So we could divide everything by 2. Okay, so I can leave it here if I want, or I could just go ahead and divide everything. I'm going to leave it in the front. So this 2 really has no impact on the answers. There's where my answers are going to come from, because there's no variable with 2. So same thing. What factors of 8 add up to be 6 is going to be a 2 and a 4. And again, if these three things multiplied together equal 0, that means one of them has to be 0. Now this 2 has no variable attached to it, so it's impossible to equal 0. It's going to always equal 2. So the answers come from these two factors that have the variables attached to it. So -2 and -4 are our solutions. And same thing here. What factors of 25 adds up to be 10? Well, that would be a +5 and a +5. And so what I want you to note here is we get the same answer twice. So even though it's only one answer, we call this a double root. All right, so that's what a double root looks like. And over here, now this one I can't get rid of the 3. Okay, 3 doesn't go into 5 or 2 evenly. So if I want to factor this one, this is where we take our a and our c value and multiply them together. So we're looking at 6. Is there any factors of 6 that add up to be -5? Well, -3 and -2. And now we're not quite finished. Now what we do is we take the numbers part and divide the numbers by whatever our a value is. So in this case, we would be dividing it all by 3. So, and then we simplify if we can. So 3 divided by 3 is 1. This one we can't simplify. So from a factoring standpoint, and we can't reduce it, that's as low as it gets. So now we just move this denominator, the 3, in front of the x. And there's how we would make the factor. The actual solutions would be 1, and then this one would be a 2/3 for our actual answers. Okay, so the next phase that we're doing here is we're going to give you the answers, and we want you to make the equation from those answers. And so as that slideshow talked about, is the very first step is to take your solutions and make the corresponding factors, knowing that your zeros and factors are always opposites to each other. Okay, so for example, if I had zeros, let's go with -3, 1, and 4. There's my, I have a polynomial, I have an equation or a graph, And there's 3 zeros, 3 x-intercepts of that graph. And I want to make an equation that satisfies that. The very first thing I'm going to do is I'm going to make the factors for each 0. So if negative 3 is a 0, that means x plus 3 has to be a factor. Just like in the beginning here, this plus 5 factor gave me an answer of negative 5. So we're working backwards. If positive 1 is a solution, that means x minus 1 has to be the factor for it. And same thing here. If a positive 4 is a solution, that means x minus 4 is the factor. So there's our first step. Take your zeros and make your factors. Now, if I want the equation in factored form, we would be done. If I want it in standard form, so I want it to look like these, now I need to go ahead and multiply these things out, which you might be a little bit unfamiliar with this. We're good at foiling, just multiplying 2 things, but now I got 3 things. So it doesn't matter the order. The commutative property applies with multiplication, so order doesn't matter. So I could switch orders. I could do these 2 first and then take that answer and times it by this. I could do those 2 together. I could even switch the order. So why would you do that? Well, let's say I had 3 and I had x minus 3. If I have those conjugates, if you remember, you can do the shortcut. So I might want to multiply conjugates together because the multiplication is a little bit easier, because if you remember, the O and the I will cancel themselves out. So from this part, it's just your preference here. So I'm going to go ahead and I'm going to put these 2 together first. So if I FOIL this out, I would get x times x, so x squared. And then I have a minus 4x and a minus 1x. So that's going to give me a minus 5x. And then plus 4 from the negative 1 times the negative 4. So now I am multiplying this binomial to this trinomial piece. All right, and so this is where you might be a little bit uncomfortable. All right, and so all we're going to do here is just like with FOIL. Remember, FOIL isn't actually a process. It's just an acronym to help you not forget any steps. But as we stated, FOIL is just the distributive property done twice, and we're going to do the same thing here. So all I have to do is I've got to take this x, and I need to multiply it to everything in this other one. So I got to take this x and multiply it to this trinomial. So x times x squared would give me an x cubed. X times negative 5x would give me a minus 5x squared. And the x times 4 would give me a 4x. Now I take the 3, and I'm going to do the same thing. So 3 times x squared. And I like to write mine underneath. You don't have to, but this, for me, it just makes it a little bit easier to combine like terms. And there's me distributing the 3. And so now I can just go ahead and add my like terms together. So x cubed, this would be a minus 2x squared, and minus 11x, and a plus 12. And there's an equation in standard form that should contain those zeros if we've done the multiplication correctly. So how can I check my answers? Well, now what I can do is I can plug in, and I have 3 to choose from. I could choose any one. I could try all 3 or just 2 of them. But I can take these x values and I can plug them into my equation. And if I've done it right, the answer that comes out should be 0. So for example, if I plug in 1, what is 1 cubed? Well, 1 cubed is 1. 1 squared is 1 times the 2. 1 times 11. And then there's this 12. So if I do the math, 1 minus 2 is a negative 1. Minus 11 is a negative 12. And negative 12 plus 12, it does equal 0, so it checks. Well, maybe we just got lucky with that one, so let's try another one. If we plugged in 4 cubed, well, that's 64. 4 squared is 16 times the 2 would be 32. And then 44 and plus 12. And then same thing, 64 minus 32 is 32. 32 minus 44 is a negative 12. Negative 12 plus 12, it does equal 0, so it does check out. And if I wanted to, I could try the negative 3 and it should work out as well. So if I do it, negative 3 cubed is negative 27. Negative 3 squared would be positive 9, so times 2, or negative 2 I should say, so there's a minus 18. Negative 3 times negative 11 would be a plus 33, and then this plus 12. So now if you do the math, negative 27 minus 18 is a negative 45. Negative 45 plus 33 is a negative 12, and negative 12 plus 12, it does equal 0. So all three x values I plugged in gave me 0 for the answer, which is what should happen. Another concept. Let's say we have zeros at negative 2, 0, and then let's say 1 is a double root. So same piece here. So if negative 2 is a 0, what factor would correlate with that? Well, it would be x plus 2. If 0 is a 0, this is where we just use x. All right, and I like to write mine when it's that. I like to write it in the front, always. That's just my personal preference. But again, I could write it right next to this one. It doesn't matter. And then 1 being a double root. Well, let's refer back to this question. We ended up with a double root here because this one number, this one distinct answer, was coming from the same factor twice. So we're going to do the same thing here. If 1 is a double root, that means I have this factor, but it's twice. It's 2 of them. And so there is our setup. And now it's the same thing. If I want this in factored form, we would be finished. If I want it in standard form, now I've got to go ahead and multiply this thing out and do all that good stuff, which is what we're going to do next. So again, order doesn't matter. I'm just going to work with as I see it. So I'm going to put these two things together, and I'm going to put those two things together first. So if I distribute, I would get x squared plus 2x from the first part. This would give me x squared minus 2x plus 1 when I FOIL that one out. And now I've got to multiply these two together. So again, I'm going to take this x squared first, and I'm going to distribute to all three elements over here. So x squared times x squared is x to the 4th minus 2x cubed and plus x squared. And now I take this 2x and I follow the same process. So this 2x is now going to distribute to all three parts. So 2x times x squared is a 2x cubed minus 4x squared and then plus 2x. And now I can combine my like terms and I would have this thing in standard form. So here the x cubes cancel. And there's my equation. So from a classification standpoint, our power is 4, so it's quartic. If you remember fourth power, that vocab word is quartic. And then there's 3 terms, so we had a special name for that. It's trinomial. So we ended up with a quartic trinomial for that piece. The problem we just did, the power was 3, so that would be cubic. That's the vocab word for that part. And then there's 4 elements, so anything over 3 we just say is a polynomial of, and then however many there are. So in this case, a polynomial of 4. So the classification for this one would be a cubic polynomial of 4. And then same thing back to this one. If I want to check my answer, well, 0 is easy. If I plug 0 in, obviously these all have an x with it. So 0 minus 0 plus 0, it's going to be 0. If I plug in 1, now I would have 1 minus 3 plus 2. Well, 1 minus 3 is a negative 2. Negative 2 plus 2, it does equal 0, so it checks. And same thing if I did negative 2. Negative 2 to the fourth is a positive 16. Negative 2 squared is 4. And then 2 times negative 2 is a minus 4. So 16 minus 12 is 4. 4 minus 4, it does equal 0, so it does check. And the last one we'll look at is what happens if I got a fraction piece. So let's go with this. Let's say we've got zeros at negative 2, 2/3, and let's say we've got a triple root at 0. Okay. So same thing. I'm going to make my factors. And the first one's easy. So now 2/3. So I'm going to refer back to the quadratic example that we did that gave me a fraction piece. So notice 2/3 factor came from 3x minus 2. So same kind of piece is going to happen. If 2/3, I'm thinking of it like this, x minus 2/3. And now, what do we do with the denominator? We put it to the front. So the factor we would generate is 3x minus 2. And then lastly, the triple root at 0. So that means this factor happens 3 times. So that would be like x, and then another x, and then another x. So I'm just going to call it x cubed, and again, I'm going to put it in the front. So there is the factorization look for this scenario. And now I can just go ahead and multiply it out. I'm going to do the FOIL actually first. I'm going to multiply those two things together. So x times 3x would be 3x squared. And then I'm going to have a minus 2 and a plus 6. So a plus 4x and then minus 4. And now if I distribute the x cubed, I would have 3x to the 5th plus 4x to the 4th minus 4x cubed. And there we would have our equation. So there is the process on making equations from known zeros. Your first step is to make the factors that go along with the known zeros. And then from there, it's just a matter of foiling it out, multiplying it all out, and combining like terms. That's where, if there's going to be a mistake made, that's pretty much where it's going to be, is on the multiplication part. So again, if you want to check your answer, now you could take one of your solutions, all of your solutions, or maybe a couple of your solutions, and you could plug them back into the equation you make. If you've done it right, the answer that should come out is 0. All right, so for example, again, I could plug in negative 2 here, and if I've done it right, I should get 0 for my answer. All right, or I could check it with 2/3 and go that part. And let's just do the classification here. My power is 5, so if you remember, that vocab word is quintic. And then there's 3 terms, so this would be a quintic trinomial is the result.